right, so now we can go down and start auction. And now here we have test first making sure that our global state auction end is not equal to 0. So making sure that our auction end timestamp has been set. And then making sure our highest bid is equal to 10,000. And that's the starting price we passed in. So both of these are passing as well. And now we can see first bid, again, very similar pattern here. And one thing I forgot to mention is you might notice, so we mark our tests with whatever group we want it to be in. And this is so if, like on our command line, or there might be a way to do it in the UI as well. I'm not too sure. We can say, go ahead and run only our first bid test, and that will easily allow us to specifically test specific parts of our contract. So that's why we use mark. And then you might notice here in each of our functions, we're passing in some arguments. And in Pytest, these arguments are actually the names of the fixtures that we want to run before each test. So here, when I run this test first bid, highest bid, Pytest knows I need to first call create app, opt in, start auction, and send first bid. If I got rid of that send first bid and try to run this, what will happen is Pytest will complain because we actually haven't initialized our, or we haven't actually sent our first bid yet. So we can see that it's still at the starting price. Again, we're always defining what helper functions, what fixtures we're calling prior to our test. And then, so again, same thing. This is one special thing to note is that here in our highest bidder key, what we're saving is actually an address. It's not just a regular byte slice that saves some ASCII bytes. It's actually saving an address, which has a unique encoding. So what we're going to do is we're first going to get bytes from hex. So this basically means our get global state highest bidder value is just going to be raw bytes. And then we're going to save those bytes in address. And we're going to call encode address and make sure that's equal to first bidder address. If we were to not encode the address and run this test, we can see that it's expecting this raw binary data to equal our address. So in order to go from raw binary data to the address, we have to call encode address. And this is from the Algo SDK. And now we have very similar functions for our second bid, making sure our global state highest bid is 30,000, making sure our highest bidder is equal to our second bidder address. And then now what we're doing here is, remember, we saved our first bidder amount. So this is the balance of the account that sent the first bid before the second bid was sent, but after their bid was sent. So what we're basically doing is making sure that after we send the second bid, the first bidder gets their 20,000 bid back. So the first bidder sent a bid of 20,000. So after we call second bid, we expect their amount to increase by 20,000. And now we also want to verify that the application has the correct balance. So our most recent bid, our second bid is 30,000. And then the application will always have 200,000 for the ASA and account minimum balance. So we're making sure that our balance of our account or of our contract is actually we expect. And finally, we have claim bid. First, we're making sure, again, these are fairly limited. There are a lot more tests that you can do. But here, this is basically just boilerplate for saying we want to test that we're making sure that the contract, after we call claim bid, is empty except for that initial MBR amount of 200,000 or 0.2 algo. And then for claim asset, we're basically doing something similar. We're basically making sure that the contract doesn't hold any assets. So that's the overall layout and how Pytest with Beaker works when testing Python contracts. Again, there are a lot of different tests that are not included here. This is by no means comprehensive. In particular, in here, we're only testing the affirmative. We're testing things to make sure that they work as expected. What we're not doing is doing tests to make sure to try to break the app. For example, running a test to see what happens if we try to send a bid before the auction starts, or what happens if we try to claim the asset before the bid is over. And so, if you are looking for things to do between today's session and next session, which, by the way, next session, we're going to be taking this app.py file and then integrating this contract into our front end using TypeScript and showing you how to deploy on testnet and connect with Para Wallet to have a fully functional dApp. So we'll be going over that tomorrow. But in the meantime, if you want to get a little bit more familiar with how Beaker and Pytest works, you can go ahead in this test app.py file, and you can go ahead and create more fixtures if you want to. So creating fixtures for doing things out of order, for example, or you can go ahead and add more tests. For example, in an opt-in test, you can make sure that it's actually opted into the right asset. Or in our start auction test, we need to make sure we're verifying all of our state, not just auction end and the highest bid. And then, of course, testing the negatives. So doing what happens when we do things out of order, what happens if we try to break the contract, what happens if we try to hack the contract, things like that. Those are all important things that you want to test that aren't demonstrated here. So this is a great way to play around with Algorand and see how Algorand works playing with Pytest. That concludes the content for today. Go to the Bootcamp repo. You can clone this repo or spin up a Git pod. Go into the session 3 directory. And here in our test app, you can go ahead and either add more fixtures to do more things to the contract, basically try to break it, or you can go down to our actual test and create more test logic to create it. Again, this is not necessary. This is just if you're looking for more things to do before the next session. And again, our next session will actually be integrating our contract into a front end using TypeScript. By the end of tomorrow, we'll have gone over how to write a smart contract, which is our auction contract, how to test it, which is what we went over today, and then how to deploy and create a front end for it on testnet.